Welcome to Neil's Narratives, and on today's episode, life goes to land. Before plants, before insects, before even the croak of a frog in the breeze, the Earth was a very different place. Imagine a world ruled entirely by water. The continents were barren, lifeless, bleached by sun and pounded by storms, with no scuttling legs, no crawling bodies, no bird song or even bugs, just rocks, wind and silence. But deep beneath the surface of those ancient oceans, something was stirring. This is the story of how life crawled out of the cradle, how Earth's aquatic pioneers took their first steps onto dry land and transformed the planet forever. And it all begins in the Ordovician period. The Ordovician period, 485 to 443 million years ago. If the Cambrian was the age of experimentation, the Ordovician was when ecosystems began to stabilise and diversify. Reefs began forming and life flourished in the oceans. Algae colonised the shallows, slowly preparing the way for something entirely new. Around 470 million years ago, simple liverwort-like plants started appearing along the water's edge. These early land plants lacked roots or vascular systems, but they were able to survive in moist environments. Think of them like mossy little solar panels, doing their best to hold onto slick rocks and pump out oxygen. Over time, mosses and hornworts followed, clinging to damp surfaces and drawing carbon dioxide from the air. These plants couldn't yet conquer the dry interior, but they were the first breath of greenery on an otherwise desolate surface. Life on land had officially begun. The Silurian period, 443 to 419 million years ago. In the Silurian period, plants evolved vascular systems, internal plumbing that allowed them to transport water and nutrients and grow taller. This advancement let them push further inland and spread across more varied terrain. Gravity, once a full-time enemy, was now merely an inconvenience. One of the first vascular plants was Cooksonia. It stood only a few centimetres tall, but its development marked a huge turning point. With vascular tissue, plants could now build height, stability, and reach towards the sunlight. Meanwhile, the animal kingdom was not far behind. Early arthropods, relatives of millipedes and centipedes, began making forays onto land. Fossils like Pneumodesmus pneumani suggest that these creatures had spiracles for breathing air. They may have been feeding on decaying plant matter or microbial films along damp surfaces. Basically, the world's first compost critics. The Devonian explosion, 419 to 359 million years ago. The Devonian is often called the Age of Fishes, but it's also significant for terrestrial life. Plants diversified rapidly, evolving roots, leaves, and woody stems. Large ferns, horsetails, and club mosses formed the first true forests, altering the atmosphere and anchoring the soil. It was the beginning of long-term climate engineering, unintentional but effective. Insects appeared during this period as well. Early forms lacked wings, but they represent the first terrestrial animals to truly exploit the air-breathing niche. Fossils like Rhineogantha hirsti may even represent the earliest winged insects. But what about our ancestors, Neil? Well, let's introduce them. The tetrapods. Some lobed-finned fish had muscular appendages with bony structures inside, precursors to limbs. These included Eusthenopteron, Panderichthys, and most famously, and easiest to pronounce, Tiktaalik. Tiktaalik had a flat skull, a neck and limb-like fins capable of supporting its body in shallow water or on land. It represented a transitional form between fish and amphibians, the evolutionary version of a Swiss Army knife. From Tiktaalik came tetrapods like Acanthostega and Ichthyostega, which had digits and limbs suited for movement in water and on land. They still relied on aquatic environments, but they were no longer confined to them. Legs were in, gills were optional. The Carboniferous period, 359 to 299 million years ago. The Carboniferous period brought an explosion of life onto land. Dense forests of giant lycopsids, spore ferns, and seed ferns spread across the continent. These plants pulled vast amounts of carbon dioxide from the air and produced oxygen in abundance. The result of all this oxygen? Enormous arthropods. Creatures like Meganeura, a dragonfly with a wingspan of over 2 feet, and Amphiplura, a millipede that could reach 2 meters in length. They both thrived in this oxygen-rich world. Amphibians diversified in the Carboniferous, but they were still tied to water for reproduction. Then came one of the most crucial evolutionary innovations, the amniotic egg. With a protective shell and self-contained environment, the amniotic egg freed vertebrates from the need to lay eggs in water. The earliest reptiles, such as Hylonomus, emerged around 315 million years ago and began spreading into dry environments where amphibians could not go. The Permian period, 299 to 252 million years ago. By the Permian, terrestrial ecosystems had matured. Forests were home to a diverse array of insects, plants, and increasingly complex vertebrates. Among these were the early synapsids, relatives of mammals, including Dimetrodon, famous for their sail-like structures on their backs. Seed-bearing plants began to dominate, better suited to the drier conditions than their spore-based predecessors. Conifers appeared, laying the groundwork for future forests. It was Earth's first real test of seasonal woodlands. Life on land had evolved from scattered microbial films and mosses to complex, interdependent ecosystems. From the earliest liverworts to lumbering reptiles and forest canopies, the Earth had transformed. This episode ends not with a single species, but with a thriving tapestry, a planet alive not just in its oceans, but across its continents. The journey to land was long, gradual, and full of evolutionary detours, but it changed the face of Earth forever. With roots in water and limbs on soil, life built a new world above the waves. Next time on Neil's Narratives, we look at what happens when life faces its greatest trial yet, mass extinction. But for now, breathe deep, look around, and know that every forest, every scurrying little lizard, and every step we take, we owe to those first wanderers. Thanks for listening to Neil's Narratives. Until next time, stay curious, stay grounded, and I'll see you next time. Goodbye.